Let's go through Likert 399 evaluation deviation. So it gives us equations and values which represent those kind of equations deviation values, and also give us the queries. And for each query, it has a double query result, and therefore we need to return double array for all of the queries. So we know we this one we can use Freud Warshall mechanism to make to iterate every vertex in already being calculated. Then for every I and j vertex, we're trying to see if it has shorter I I ik and a kj, which is smaller equal to ij. Ij, if it is minor one, we can consider as the integer maximum. Um, that one, it will be O vertex 3 time complexity. Today, we are going to use another method called use a DFS plus memo to do this. And for DFS memo is that for every evaluations, we have the values, right? And then for this kind of for the queries, we just DFS trying to see if there is a result, right? And if when we query every time we DFS, we also save those kind of on calculate division to our our memo. And for this one, because the equation length is smaller equal to 20, right? So we'll see the vertex is at most 40. So it's kind of dense or small way, right? We can still use adjacent matrix. And of course, we can also use some adjacent map, right? Adjacent list. Adjacent list, the time complexity will be related to the age. In the adjacent matrix will be the vertex, right? So uh, to get things clear, because this is small number, we can still use the way convert this to adjacent matrix. Let's write code for this. We'll say int n equals 0, and we're going to have map integer. Let's convert those kind of strings to integer. And for array list of string equation, equations, what are we going to have? We're going to have for every string as equation, going to have if map doesn't contain key s, right? So we're going to have map put s n, and also we should increase n, right? And we're going to have a double. This is actual memo, right? The double n multiple by n, right? So what we do is for if I put to 0, I smaller than n, I plus plus. For into j equals 0 is smaller than n, j plus plus. Then what we have is that d I j equals if I equals 0, right? Then that will be 1.0. Otherwise, it will be negative 1.0, right? So what do we do is that because we already so there is no contradicts, and also for the map, um, we always have those kind of strings, so we can firstly from the equations to set the initial value that is for int I equals to 0, I smaller than equations of size, then I plus plus, right? So then we have int u equals map dot get equations get I dot get 0, and let's see v equals this one get 1, right? So let's see d u v equals values I, and d v u equals 1.0 divided by values I, right? Then we're going to have q into q equals to queries dot size. Then we're going to have a double result equals new double q. So what did we do? The 4 into I equals to 0, I smaller than q, I plus plus. So we're going to have string s1 equals queries get I get 0, right? And s2 equals queries get I get 1, right? So let's say if a map file contains key s1 or map file contains key s2, right? Then we're going to just have a result I equals minus 1, 1 right? And for this one, we need to continue. And then let's say int u equals map dot get s1, and v equals map dot get s2, and result I equals dfs u v. We are usability 的 new Boolean variability 的 and also d, right? So return result. So the DFS will be passing this kind of private double double DFS. So we're going to have int start, int end, Boolean array deleted, and double memo, right? So we'll say if the memo start and done equal to -1, right? Then um then we're going to have for this one, of course, you will say uh, sometimes this actually um, double, right? You should write actually you can write a mass of absolute value minus one minus to like this, right? Plus 1.0. Because it's minus minus. If this one mass dot so value, right, smaller than something like this, right? But for this one, uh, right, this one equals minus one should be fine, right? Because we set that is accurate value, and it has just a. You say that because this double has only didn't see anything, but because um there is some kind of accuracies, right? So there is no, and it should be fine because this one is like this, right? So no matter what its accuracy it is, so we just return memo start end, right? And we'll say if memo end start then equal to minus one, right? So if this one has value, we can return 1.0 divided by memo end start, right? And then we'll say if start equals and we're going to return 1.0 and we're going to have a result double result equals minus 1.0, right? And um, for int I equals to 0, I smaller than um, n, right? So there is no n. It is weighted length I plus plus. So what we have if I equals start or memo start I equals minus one or visited I. In this case, we need to continue. Then we are going to have visited I equals true and also have visited I equals false. So in this case, we will have double answer equals DFS I and related memo. And we'll say, so the thing that if answers found equal to minus one, and we're going to have results equals memo start I multiply answers. And then after calculate this, we should also save memo start and equals to result return result. Right? So this is a second solution, right? We use TFS and memo. So let's also write the Python code for this. So we have vmap V map, and also n equals this and the zero, right? For equations in equations, and for V in equation, if V not in V map, if V map V equals n, and we have n plus equal to 1, right? Then we're going to have a D array, D equals minus 1.0 for multiplied by n, for unstored in range A. Then we'll say for I in range A, we're going to have D I equals 1.0. Okay. Then what we do is for I S1, S2 in enumerate equations. Then we'll have U V equals V map S1, V map S2, right? Then we'll have D U V equals values I, D V U equals 1.0 divided by values I, right? Then we define our DFS. DFS, right? So we're going to have start, which is an int, and it is an int related, which is a list of boolean. And this one is going to return a float. So what do we write if the start and equal to -1, we return the start and we write if the end start equal to -1, return 1.0 divided by the end start, right? And we'll write if start equals and return 1.0. Then we do DFS. So we're going to have we can set value to the start equals true, right? Set here for I in range and so it is if I equals start or value to the I or the start I equals -1, we should continue. And then we'll have answers because DFS I and related. So I say if answers are equal to -1.0, we're going to D start and equals D start by multiple by answers, right? We return the start and as return -1.0. Okay. So in our main function, we're going to have result plus this. Then for A, B inquiries, if A not in V map or B not in V map, right? Result should append and minus 1 power else OK 好 VT 的 VDT 的 let's say this one force multiplied by n, right? Then we're going to result append DFS. DFS V map A, V map B, and VDT. And in the end, we just return result equals okay. So doing like a DFS and memo, we'll see. Um, here because the only problem is that we use a adjacent matrix that will be O V square, right? And for the DFS and memo, so there is Q queries, and for each query, at least we visit each vertex once, right? So that is Q multiplied by V. So the time complexity will be O V squared plus Q multiplied by V, right? And space, we use adjacent uh, adjacent uh, um, matrix, so it will be V squared, right? And also, if we still can use the adjacent list for this question, that the time complexity will be OE, that is the number of equations plus Q, right? And space will be OE plus Q. So this is the second way to solve this. And because the equation length is very small, so even like a florid matrix that is OV cubic time complexity still pass, right?